Hi, everyone. Welcome to work group workload-aware scheduling. This is July 30th, and we have a couple of agenda items today. And let's start with the first item with the NFD and topograph cap.
Yeah, thank you. So hi everyone. My name is Eduardo. I'm a NFD maintainer. For those that don't know, NFD is a Kubernetes and has been a Kubernetes for over 4 years now or something. And lately, I've been discussing how can NFD play a role in both topology-aware scheduling and workload-aware scheduling. NFD has been kind of like a slowly building some feature set to help schedulers. Yeah, I see chat conversations. Yeah, to help schedulers make decisions. The latest additions were made last year and this year for multi-cluster aware scheduling, and for we did an awesome effort with Huawei on edge scheduling with NFD. And now what I've been working on, and can I present?
Yeah, I gave you permission to present. Let me know if you have a problem. Yeah,
Yeah,
you can now.
I can present. Yeah, where are my slides here? Here. So what I want to talk about now is that we have two KEPs inside an NFD, so are not Kubernetes KEPs, but KEPs of the SIG. And they together, I feel, would add a lot of value for this working group. And I'm basically coming here to request feedback from the community. We want to move these KEPs forward as soon as possible, but not as fast that we are not listening to the community and we are not getting feedback from the community. So what I see as a NFD maintainer, and I've been trying to build over these days, is everyone is building a topology system in a different way, and everyone is creating different labels, annotations, and different methods to kind of like annotate their nodes and clusters on where is what, right? But we have NFD as a SIG project, and NFD already provides the node feature and node feature group CRDs that have been tested and are battle tested because they have been around for like 2 or 3 years. And they already serve the need for cloud provider labels, for external tooling, and for many other use cases that I have seen while collecting user stories on how people are doing topology aware scheduling. Where we want to get to is NVIDIA has this project that is called NVIDIA Topograph that collects all the topology of the system. And in the end, it does an NFD thing that is creating labels, right? So NFD lacks that middle part of realizing where everything is, where the switches are, which nodes are connected to which switches, and advertising that. Q already has a topology aware scheduling that if we could teach Q to use node features and node feature groups that are exposed by NFD, we could make better decisions because what I'm about to explain here. So Topograph, it's a project, again, by NVIDIA, that it discovers, it runs an internal logic of graphs, and then it publishes labels to tell the schedulers which nodes are connected to which switches, basically, like in a very raw speaking, right? So it creates a series of labels that tells you this node is connected to this switch and this switch is connected to this other switch, and allows you to have this tree view of a cluster, right? As I'm kind of like showing here, like it's a leaf, spine, core kind of like view of the cluster. What we are proposing in NFD KEP is have kind of like decouple NVIDIA topograph and turn that into what could be, I'm proposing as a name, the NFD network topology updater. Why the network topology updater like that is because NFD already has a subcomponent that is called NFD topology updater that is for people doing NUMA-aware scheduling. So NFD already advertises NUMA. So this is why I'm saying NFD is really good at helping schedulers know where things are. So on this cap, I am proposing we take topograph and turn it into an NFD optional component as the topology updated that is also optional. And it will give us all these five steps. And why the prune even? NFD has a garbage collector component that in the end, when you uh, remove NFD from the system, it removes all the labels and of the objects in case you want. So this is one of the caps that I'm proposing. And the other cap is NFD has an API that is called the node feature groups. But this API, as it is today, and why I want to handle this as a cap is because it's an API change that might break people already using it. So I want to be very careful with this. Is if we use the node feature group API as it is today, a regular CR on a 1,000 to 1,000 node cluster could break its 1.5 limit, right? So we want to be able to create nested groups. So the node feature group feature in NFD allows you to create kind of like pools of nodes based on the node features, right? So you can create these small CRs that tell you this list of nodes all have a GPU. This list of nodes with NFD, you can be as like this list of nodes have a USB plug, and this list of nodes don't have a USB plug. Like NFD has a lot of knowledge of your nodes. So we can create these pools of nodes. But in a big cluster and with AI workloads, is we have big clusters, and big clusters means a lot of switches and network topology. So we need a way to say like these pool of nodes are connected to a switch. This pool of switches are connected to this other switch. So you kind of like get the story of we want to be able to create pools in the same tree way of looking at things in such a way that then schedulers can very easily traverse these nested node feature groups when trying to do topology aware allocation. How this will look like, so we already did a proof of concept with Dimitri, that is the NVIDIA topograph maintainer. And this is how the node feature group would look like. And we already did a small kind of like in a kind cluster. That's why it's only 4 nodes. But we can already create a node feature group that aggregates all the nodes that are connected to one switch on a cluster. So you can now imagine this would be just a small list, right? Because a switch can only hold many nodes, like depending on the type of switch. And then you will have multiple node feature groups collecting the switches of your cluster. And the caps are here listed. So for the recording to have them. So the caps are basically the pull request 2551 and 2553. I really want feedback from the community on does this help? Does it contribute to projects like Q, to Volcano, to Kai that are schedulers, the most known schedulers by the community? What I'm not seeing, if the API can also be added to something else. So I really want the community feedback so NFD can play a role in topology-aware scheduling. And yeah, thank you for the space. Now I leave it up to questions.
Yeah, I think this is very relevant. I will say that like one of the areas I'm working on downstream is trying to figure out like how do we offer something like queues, topology aware scheduling for on-prem, and honestly it's a gigantic mess. I don't think we don't really have a solution. I actually like the idea of, yeah, topograph is probably the best option we have. Uh, I am curious on like NVIDIA's, maybe as a vendor, like Topograph lives in NVIDIA's repo, and like accelerators do depend topology depends pretty heavily on accelerators. And there's AMD and Intel. I don't know like even like what the options are for different device vendors, and like whether or not like it's Topograph something we can be general for, not just NVIDIA, or would we expect like Intel or AMD would have their own like hardware discovery, or Google has their own for do obviously Google has their own for their cloud provider, but
Yeah, both Google and AWS, when you create like an EKS GKE cluster, the nodes already have labels that are for topology, right? So they already have like their internal controllers doing that. So where I want to get with this is NFD is a Kubernetes 6. How about we work as a community and standardize this? We standardize the labels, standardize how they get created. And from my point of view, and what I want to push, and I am pushing internally at NVIDIA, is if we make topograph a subcomponent of NFD, then we as a community expand current topograph from just serving NVIDIA to serving generic hardware, right? And we are trying to keep the API of topograph very generic, talking about trees, right? Like leaf, branch, root, blah, blah, blah. So we can then plug that to the very generic concept of a node is connected to a switch gets connected to multiple switches. Like I don't want to put names on that. So that way we can be generic to AMD, Intel, and any vendor.
I mean that sounds great. I'm supportive of that one.
Pavel?
Yeah, so one comment which I think left on the doc is related to like the API, because like both queue and task implementation in Kube Scheduler relies on node labels. So I don't know if this is this is part of like the proposal to consider like integrating with the resources themselves, which are proposed, but from the scheduling perspective, like coming with a set of standard labels and making sure that those will be exposed by default would be like the most straightforward way to make sure that different schedulers will be able to utilize those and basically to get almost immediate adoption from the scheduler side. So is there like apart from agreement on like the naming of the labels and so on, is there any like problem with pushing harder on like coming up with those labels? Are there like any for instance technical constraints? So I've heard, for instance, that that the one of the limitation of the labels is that it's quite easy to have like a tree representation using them, but if the actual structure is, for instance, a DAG, then this becomes like more complicated, and with like multi-level switches structure, it's quite common not to have like a simple tree, but actually like it's like hierarchical DAG.
I'm aware of that, right? Like, for example, we can talk about NVIDIA or Google TPUs, where we now have these architectures where you want the nodes to be sharing memory. As my point of view, NVIDIA is the NVLink, right? And for the TPU side, I don't know the name, but that creates like an extra complexity. You don't just want the nodes to be on the same switch, but you also want the nodes to be connected to this memory sharing mechanism, right? And this is why I'm also proposing not just using labels and annotations, but you kind of like leveraging NFD APIs, right? We have no feature and no feature group. And that's why one of the KEPs is modifying the no feature group API of NFD to have nested list. If we can do that nested listing, then we can do more complex cluster representations via the NFD API than just putting labels on nodes.
Okay, so I understand that there are use cases where like a dedicated resource would be like better suited. I'm just asking whether like starting with labels just to make like the information easily available for the existing features in the schedulers wouldn't be like a reasonable target.
That is part of standardizing things as community, because labels, they have a size limitation, right? So you cannot have a label that is too long, and that itself creates the limitation. So we can create multiple labels, but that is also a problem, because as an NFD maintainer, for example, if you turn on all the labels that NFD can create for a node, it every node object basically becomes it reaches the itsy limit. Like NFD can create like hundreds of labels. So that's also we need to standardize, like how complex do we want to get in these first steps, right? Like, do we want to just define a tree structure for clusters and then we start complicating ourselves, or we want to be complicated from the beginning, which is not the way the community moves. So I would say we can start with labels, very easy labels, assuming a tire structure, right? Like nodes to switches, switches to switches. And then we can, from there, start complicating our lives a bit.
Okay, because like both at least Q and Kube scheduler, they have like limited set of potential constraints which can be defined when it comes to tasks. So I think it. I understand that with like the resources, you can convey much richer information, but in order to utilize this, you need also a way to define like a meaningful scheduling constraints on the workload side. So like things like minimum throughput or maximum distance for the workload or things like this in terms of the topology, which are not present right now, at least in the standard schedulers, which I know. So even if you will make this rich information available, it will take probably quite a significant amount of time for the schedulers to be able to utilize this information to do something meaningful with it.
I don't see that as a blocker. I love your feedback. From your feedback, I'm like, I have nothing to say. Like, I love what you're saying.
Okay.
And yeah, like, it's like, if I can do what I'm planning, like what I have in my head for NFD, then my job also becomes on going to queue meetings and like working with the queue team on, hey, how can we help and integrate? And I know it's going to take time. Yeah, for sure.
I don't want to take too much time, but one more question which I wanted to ask is about the relation to DRA, dynamic resources, because like at least some aspects of network topology can be expressed using multi-host devices. So basically, you can model like a set of nodes which are connected to each other by multi-host resources, and then basically have constraints like networking constraints expressed through some resource claims. Was this like somehow researched or I know that this probably would come with some limitations, but I've heard some discussions, at least for TPUs and vein network topology, to be represented as a DRA resources, and I think for NVIDIA there is like compute domain and related DRA resources representation, which to some extent also like touches on the networking structure.
No, not direct connection with DRA. Yeah, but I am aware of compute domains. I was there when compute domains were created. So yeah, compute domains allow you to define what I was saying for GPUs and TPUs, these nodes that are connected by the memory sharing mechanism. So it already kind of gives you a topology, right? Because a compute domain is a topology of the system that you know that is close to each other. So, and is being exposed via DRA. So no. Again, I'm coming from the NFD point of view. I'm the maintainer of NFD, so I'm kind of like championing for NFD. But of course, researching for DRA is a good feedback.
So far, I don't feel like there is any blocker for this, and actually we can use it to, with the composite bot groups and all these features. I think it might be easier to use this feature. So I don't see any blockers so far. So let's continue reviewing the two caps, and let's see how it goes. Thank you so much. The next item is bubble.
Yeah, one thing I will say for the feature, the API one, it might be worth reaching out to the API review now that we're out of the cycle, just to see like their thoughts about like how we could do this. I don't really feel like I can really help you review 2551, but I think maybe that is a useful thing to try and like ask. I think, yeah, I'm definitely supportive of both of these efforts. I don't know how much I can really help on the review side because I don't have much NFD experience. But yeah, I'd suggest using that one, using the API review to help maybe figure this one out. But anyways, thanks.
Thank you, Kevin. Yeah, I will make note of that and reach out to the API team.
Thank you, Kevin. Pavel?
Yeah, so I added an item to agenda because I actually have like this is more like open-ended question to people who have some experience with NVIDIA's compute domains, because I had some conversations with Q team, and like there was a question whether basically compute domains couldn't be like created dynamically as a part of the scheduling process. So basically when the pre-binding for the workload happens in the scheduler, especially in the case of workload-aware scheduling, we could like delay this and have some workload-related logic injected, which could like create some resources or do some configuration of the nodes based on the scheduling outcome. So in a way, this is similar to what basically DRA does, but more on like the whole workload level. So I just basically wanted to check with attendees if you are aware of any challenges related to resources like compute domains for NVIDIA, which basically needs to be managed somehow for the workloads, but potentially could be like dynamically managed as a part of like the scheduling process.
That is an interesting conversation because that would mean compute domains not being just for the IMEX domains, NVIDIA proprietary, but to maybe like think on a more generic cloud native way of compute domains. So
yeah, so like one potential way is to have like just some extension point defined in the scheduler, and basically have NVIDIA compute domain as a like one of the implementations of this of this extension point. So we probably this couldn't go to like the core Kubernetes, but we could have like a out of three plugin for the kube scheduler, which could basically, at least to some extent, automate the management of compute domains. But we could also potentially consider having more like generic extension point, which would probably need to operate on some more abstract resource, which would not be like NVIDIA specific. So I think both options could be considered. I'm mostly interested whether some automation around like the creation or management of those would be something which the community would be interested in, and whether it would address any issues like some users face.
Yeah, Andre.
Yeah, I just want to quickly say, I think we talked about this before with John. I think the conclusion, not the conclusion, but like one of the idea was that, we just basically create the pod groups, and the resource claim template will reference the specific location, then it will automatically create the compute domains because we have a specific device class. I just didn't know. I know that I think we had this discussion like half a year ago, and after this, I know that Kevin is still working on the project. So we need to kind of figure out what will be the next iteration of compute domains, even that right now resource claims can be defined in the pod groups, right? Do we have any updates there or not really?
I haven't heard about anything around this. Yeah, so like the support for DRA, like pod group level resource claims is there, but I haven't heard about like specific use cases behind this.
Yeah, I guess the main differences was like go all the way around. So from my understanding right now, the compute domains create resource claims, but all the way around, resource claims will create compute domains, and then the workload will be placed, right? But I guess we need someone from DRA, NVIDIA DRA driver to come and see if they kind of align with this proposal, right?
Okay. I will probably try to reach out and get some like more information. So probably like the DRA people should know.
Yeah, I think we might need to have another conversation next time and invite John Palmer to the meeting, and we can open the discussion again, because as Andrea mentioned, we already had this discussion, but this was before the topology aware and composite and everything. So let's reconvene now and see where we where we are and now we have, and continue from here. But actually, we are very interested in this conversation. So let's continue this conversation here in the working group. Okay. Any other question related to this topic? Right. I just wanted to, the next item is wanted to just make everyone aware with the queue integration discussion that is happening in work group batch right now. And Pavel had this slides today to introduce strategy to integrate WAS APIs with Q. I just wanted to give attention to everyone about this, and I know that the discussion just started. We have a lot of open questions from the work group batch. I'm not sure if we should continue the discussion here or having a separate meeting to continue this discussion. Just wanted to bring everyone attention to that. Yes, Pavel?
Yeah, as you said, there are like multiple aspects of the integration, and like I believe that most of the work related to the integration will actually need to happen on the Q side because quite like significant changes to how the scheduling on the Q side is orchestrated will need to this logic will need to be adjusted for the integration. But one cap on the Q side, which I think might be particularly interesting for the WAS community. I can try to find it after the meeting, but basically the proposal is to use Q specific labels and annotations to create WAS pod groups for groups of pods. So Q has a feature which unfortunately is called pod group, which basically allows to add like a label and annotation on some group of pods, and this basically allows to Q to handle this set of pods as a single unit of admission and scheduling. So the proposal is to allow Q, probably behind some like feature gate and so on, to create WAS pod groups for those pods and basically assign those pods to a pod group to basically enforce scheduler to also handle those pods in an atomic way. So this basically allows to Q act as a kind of workload controller for a group of pods and to manage the pod group for them instead of relying on the controller behind the pods to do this. So I think this is interesting proposal, but I think it would be good to get a feedback on this proposal from WAS community, especially the people working on like the controllers integration.
Yes, Kevin?
Yeah, I linked at least, I think the cap you were mentioning. I know I linked it there. Yeah, I think from the Q side, sort of struggling on whether or not we keep these annotations and support them or we try and phase them out. That's sort of the challenge I'm dealing with Q, because like we obviously Q's TAS is pretty far ahead of entry at the moment, and given that the APIs are beta, that it will be that way for a little while. So, and that's where like I'm struggling to know from the Q community whether or not like we keep, the annotations. I mean, even the WAS pod group kept that I have, I don't think we should include support for creating like the TAS information or even resource claims for pod groups. I think the API for that would be pretty gnarly. And that's something I'm trying to piece together. I like the proposal that, well, I also opened up another one yesterday on, at least for Q, like what can we do if people bring their own workload or pod group, and having that kind of adopt the information for Q. And I think that could be at least an approach that we take for controllers that don't yet have the integration. But my overall, the biggest hope I have is all the controllers, we start adding support for WAS and the controllers, and then Q needs to react to that, and not really the way that Q's kind of been going, where we are sort of adding whatever we want in Q, and kind of like there we have some, like I am running into a lot of downsides with how Q has like Q's TAS isn't aware of like DRA, and then there are interplays of like, you know, we're talking about like network, basically using DRA for network devices that span multiple nodes, and then you also are using DRA to do NUMA placement within the node. That's not really handled that well with Q. And I think like I don't think there's a world where that would be handled that well with Q. And that's kind of why like I like to kind of want to piece together like, the responsibility for Q and WAS going forward, because like Q is not going to be able to tackle all of the scheduling stuff that's coming up. And anyway, that's at least the vision that I'm thinking we need. But I also think there is a cross alignment with Q and WAS that needs to happen, because I know I've had some discussion with the maintainers on Q, and there's a lot of GA users of Q, and we can't disrupt them. So that's sort of probably the biggest challenge we have.
Yeah, and as I mentioned in the chat, I think the main thing in this working group that we need to draw the lines between what Q should support versus what was Cube Scheduler should support, and how they can work together without interrupting the Q or the Cube Scheduler, of course. And I'm glad that this conversation has started, because we need to continue this conversation. Andre, do you have anything?
Yeah, I think just quickly, I definitely agree. I guess the question would be what the role Q will play in the ecosystem, and then what the role of the Cube scheduler will play. I think we discussed this a little bit before, like the broader kind of multi-class orchestration, capacity management, and all the things which belongs to Q will still be in Q. But at the same time, like the Cube scheduler should make a decision for like things like, gang scheduling, node assignment, other things, disruptions, right? Which also could, correlates with all the features in Q. So I guess my question is like, do you think, Kevin, like from a maintainer's perspective, they should be fine to deprecate those capabilities in the future? And how hard it will be for existing customers to see those deprecation coming in?
I think the challenge we have from Q, like Q's TAS is pretty well used, and not all of the API features match with what we have in tree. And like there are other things that Q's TAS is doing that as of the moment the scheduling work is not doing, like removing unhealthy nodes and other stuff. And Q's TAS, there's a lot there, and I think that's the challenge is like a lot of it's an annotation label based, which makes it challenging really to like the API is a little rough. There's a lot of stuff. There's a lot of features there. I don't know if everything needs to be in tree in the scheduler, and I think that's where I don't know the answer for Q if we eventually deprecate like Q's version of TAS. Maybe in the eventual world we do, but we kind of have this complexity we have to deal with right now.
But do you see the topology, like the tasks will be kind of evolved in parallel? Like, because from my understanding, tasks and queue also in beta right now, right? It's on GA.
It's GA.
Okay.
For Q, I mean, I think they have, at least I think from Google, they have major users of Q's TAS, and I think that basically they're not going to disrupt those users, from my understanding. So I don't think I'd treat it like it's basically GA. Beta on, for all intents and purposes, is GA for Q. They have a lot of features they're adding to it. The major gap that we have with TAS Q is there's no integration yet with DRA, which is what we're hoping the scheduler library will piece together. But yeah, I think that's definitely a piece. I'm not probably going to be able to lead anything around the TAS work. What I'm seeing internally is, like, for inferencing, a lot of people want like topology aware scheduling and gang scheduling, but they don't really need all the complexity of Q. Like, a lot of times people are they're creating clusters dedicated for inferencing, and they want to be able to, place their pods in a performant way without having to worry about like preemption or anything like that. And I think, like, what I see is going to be very useful for people, because like they may not want to have use Q, and then I hope over time controllers integrate with workload aware scheduling, and then Q kind of correctly reacts to that. That's at least like what I think is going to happen, because like no matter what, I mean, Q is a very big and popular project, but not everybody is using it. And that's why I think having these solutions that stand alone in core Kubernetes is important. And that's at least kind of what I'm seeing and from downstream and conversations I think we had even at KubeCon back in March.
Yeah, actually, I mean, from my perspective, and I'm not really a maintainer of Q, but again, just want to say, like, I agree that, controller owners should be responsible to integrate with VAS, and Q just should be able to reconcile those integrations, right? Which means, like, if controller owners want to have tasks coming from VAS, they should be able to just use Q for, like, other things like capacity management, multi-queue, etc., right? That is why, like, I don't really think we need to do much integration on the queue side, bring your own pod groups, bring your own workloads. I don't know, like, if this is really super important, to be honest, like, as a first step. Yeah.
Go ahead.
If you recall, Kevin, I already pasted this conversation. We had this conversation on Slack before. So we agreed that Q will integrate with Kube Scheduler tasks and all all the functionality that is supported now from Kube Scheduler, and like via the Cube or the scheduler library that it's being produced right now. And anything else that is like over and above or extra, and it's not implemented or not supported by Kube Scheduler tasks, it will be kept in Q, supported on their way. So Q needs to figure this out. Q needs to shift their design a little bit to move from supporting extra features that they don't need to from Kube Scheduler, because it has been already supported in Kube Scheduler. So they need to remove it. They need to retire it and use whatever they have in Kube Scheduler right now. Anything that is like different from these two, it will be kept supporting in Q. So eventually, what we agreed on, that Q will be responsible for managing the quota. Like I believe the quota. I believe this is like the main thing. But binding anything else like related to read scheduling, it should be supported in Kube Scheduler, and it should be integrated from Kube Scheduler. I'm not sure if anything has been changed since then, because your proposal makes Q not queue at all. It's like they consider it as controller, which we shouldn't do that, I believe, because we will have like 3 layers of like controllers now. If we have like job set, for example, so the job set will create pod group, queue will create pod group. So
the proposal that I had was Queue has an integration called pod integration, where you can say, I want a group of pods to be considered, Queue considers them a pod group. In that case, there is no top level controller. So then, I mean, we could just completely ignore that proposal I have and just say Queue will handle that one, and we don't care. That is an option. I was thinking at least this gives us an idea of, yeah, I mean, that, like, I think this is more a question for Q about like what they want to do about their annotation based pod groups. There is the problem of why I want to think about this is that integration point is used for leader worker set and stateful set. And so like overall, we probably would want to use the in-tree API for that. And even if the cap does end up just being at the end of the road, like we forbid in Q, like if you're specifying a scheduling API, you cannot use Q's pod groups. Or you could. My goal would be that basically, in order for this to work in Q, the pod group, WAS workload, and Q's workload all need to match. Like there's no like Q, like we can't have a divergence where, you know, Q is admitting something very different from what the scheduler sees. That would be essentially, we are back to the race and a complexity that we want to avoid. So yeah, I mean, I think
I believe we would need, I believe we would need to introduce like a translator layer in Q to solve this problem. Pavel, please let me know if you have this in your plan. But is it part of your plan to integrate Q with WAS is to have like some sort of translation layer between the workload here and workload here, pod group here and pod group here?
Yeah. This is exactly as you said. So basically, the plan for scheduling scheduler library is to expose some workload level simulation function. So basically, that you could pass a set of pod groups, pods, and composite pod groups, which create a single workload and ask the scheduler library to run like a full schedule workload logic for those. This the plan is to expose this in the scheduler library, and in order for Q to be able to use it, Q would need to basically translate its own workload representation to basically a set of pod groups and composite pod groups.
So I think you shared the strategy with the community before, but maybe it's not updated because all these small details, I believe I cannot, I cannot track it from here a little bit. So is this the right place to track this plan, or if there is any other document that you would like to share to get more perspective?
So, I think that the most appropriate place are three umbrella issues, which are created in the Q repository. Those are quite descriptions for those those umbrella issues are quite high level, but we should probably this is probably the best forum to have some follow-up discussions about and implementation details. This like translation logic on the queue side. This is something which at least according to like the current plan will target with the 0.21 release of Q. So probably in October, November timeframe.
Okay, so I think what the issue that you're talking about is like the deep integration between WAS and queue implementation via scheduled
Exactly.
workload. So Kevin, do you think that by reading, like the plan on this issue, that this will cover your concern related to the proposal you have and related to the LWS and job set integration with Q?
I haven't really seen anything around the scheduler library overlapping with the different workloads. I see it more for basically phasing out a lot of the in-house scheduling logic we built for Q. Maybe the goal eventually would be different with the scheduler library, but like I think the issue is Q kind of has their own scheduling logic built in there, and Q, a lot of the internals of Q don't care about the workloads. There's another functionality in Q called like the job framework, and like that the interface for this is where like I think that would be where the converter would probably live for like how do you translate like a job API into the pod set or into basically the Q workload. And that I see is, at least to me, I think that's different from the scheduler library, but it's all related, but like the scheduler library sits in a place where like Q does it, like at a certain point, Q will translate all the true workload APIs into the Q's workload object. And that's what's kind of the Q scheduler works on. And I think that's where like the scheduler library fits. But then you have the workload integrations, and part of it is also getting these APIs stable makes it more serious that Q needs to take this effort. It's kind of like where like the Q community is aware of this. Like we even have a periodic running where we're making sure that nothing's breaking Q when we have the WAS APIs enabled, and we are following a lot of that. But yeah, they're like,
so I think we have two problems here. That Q has a lot of Q scheduler function or scheduling functionality in general that we need to extract, because this is not the right place for Q, and like they have to do it anyways because Cube Scheduler doesn't have it, but it has it now. The second problem is the integration between Q and true workloads that already integrated the ones, right? So the first problem, I think, it's being solved now by the scheduler workload library. So I believe this is the like the motivation, or like the vision from having this library. And please, Pavel, correct me if I'm wrong. The second problem, which is the integration with the true workload, my logic says that if they are using the workload and bot group for the WAS, and the queue knows about them, so the problem will be solved, I believe. But if this logic doesn't work, please let me know.
Yeah, that's basically it. And to me, like the big goal is, I think Q has a lot of things it's doing, and like one of the things that like I don't know where this is internally or externally in Q, but like they have examples where they want to queue the individual jobs within a job set to do like preemption within the job set. And that's something that they are interested in supporting. They kind of done that. Like that's sort of how I think leader worker set works, where individual pods within the leader worker set are separate queue workloads to enforce like partial preemption. And that's where like I think the integration pieces get tricky. And that's where like I think we're still piecing together some of that. And then yeah, I mean, I think that's at least my mental model. I don't know how well if that matches kind of with your vision. But
so just time boxing here. We already overtime. So if you are okay with continue for other 5 minutes, or we can stop the conversation now and we can continue next time. What do you think, all?
yeah, that's fine with me.
Okay, Pavel, Andre, you're okay with that? Okay. Okay,
Yeah.
thank you, everyone. So this proposal that you just mentioned, it's just related to LWS problem, right? It's like they wanted a specific sort of preemption, like functionality for this specific workload. We can talk about this, but in general, this is, like we just need to draw these border lines so we can know how to integrate with it.
It's for
right?
all the workloads.
Yes, exactly. So all the functionality related to Kube Scheduler that the Kube Scheduler is doing it right now, it should be deprecated or migrated. Do we agree on that? Bubble, I think this is the thing that we are moving towards, right?
I mean, we have no control over what Q does.
We have, sorry?
We have no control with what the Q community decides to do. Like
we have because Pavel is here. He already has the conversation with Q maintainers, and Q maintainers have this conversation in Slack with us that anything related to Kube Scheduler needs to be retired or need to be replicated, and they will use the Kube library, the Kube Scheduler or Scheduler library instead. If this is not true, please let us know. Pavel, please, I need your help here.
So definitely we want to move in this direction, but this does not mean that like the existing features on the Q side can be like deprecated soon, because the Q is well ahead of WAS when it comes to more advanced scheduling features.
Yeah.
So for prolonged period of time, basically Q will need to support like two modes where it will be like using WAS, which will provide like a full compatibility with scheduler features, but it means some of the more advanced features developed before WAS in Q will not work, or basically the current mode where some more advanced features from the scheduler side will not work with Q. And
this is totally fine. Yeah, this is totally fine. The difference will be kept in Q, and it should be stable, and it should keep working. And we should make sure that like while implementing WAS, we're taking care of that. Like we need to take care of the two pieces. But if we have a feature in Kube Scheduler, or if we have a feature in Q that is already supported in Kube Scheduler right now, the ultimate vision, or like the end goal is to deprecate this from Q and use it from Kube Scheduler, right? by time. I know it will take time, of course, but this is the direction that we are moving toward. Is that right?
So the question is, what do you mean by deprecation? Because
replacing, replacing. It's
yeah. So if the feature works like exactly the same between like the Q implementation and WAS implementation, then there's no like deprecation, because
exactly,
like the feature stays. What we can discuss is deprecating some Q specific APIs for basically defining a given feature. So I think we in my opinion, this should happen to large extent like naturally with basically more controllers and like reference solutions adopting WAS. Basically, people will switch to WAS APIs. So I'm not sure whether we need to have like a strict deprecation policy for Q features which overlap with WAS, but definitely when we'll have like a standard way of defining a given feature, we should encourage people to switch. So
it's not a deprecation. Sorry for using this word. It's an internal change. So the code internal, like the internal code will just like be updated to use Kube Scheduler instead of the custom scheduling code. Is that the right description for that? But the feature will be kept the same for the user, for the end user. They don't notice anything, but I'm talking about the integration behind the scene.
There's a lot of components, but yes.
We need to list them. We need to know them so we can start to tackle them one by one.
Yeah, the scheduler library, I think, handles the TAS and bridges the gap with like DRA and other stuff and bringing that into Q. How do we, like, with the main goal is like, for the job controller, like we would want basically the job controller's API for scheduling to influence Q's workload. And like, that's like the goal. Like if we can get all the integrations that, like, if we need basically proper scheduling APIs in all our integrations, and that would kind of cause Q more to react to this versus like, because Q is doing a lot of the annotations basically serve the purpose of how Q is doing gang scheduling, and we kind of need to piece that apart. And I think the way we're going to do that is by adding the support in the controllers themselves and making sure that Q doesn't manage its own workload or pod groups.
Right.
But the problem is a lot of people don't use workload controllers for this. They use their own pods, and that's sort of why, like, that's why I have the KEP on what to do for the annotations and how we could at least create the pod group so we have gang scheduling. And that was like at least why I took that approach, because like we are seeing a lot of users that don't use job set, or even controllers we know about, and they're kind of managed and they're having Q and they're leveraging that. And like I've seen that from quite a lot of organizations, and I would prefer that was not the case, but it is.
From previous conversation, I believe we will bring WAS to deployment. We will bring WAS to stateful set as well. This is the plan as far as I know. So I believe if we already integrate WAS with the deployment, stateful set, job, and the sub projects as well, the user, I don't know if they wanted to use just pod, like bot template. We can talk about this. We can talk if we need to, like implement it for replica set as well. But at least this is the plan. This is the ultimate plan. So hopefully by time all these unnecessary or extra queue supporting for the missing pieces, it should be replaced by the right implementation by time. This is what I like I provision like the ultimate plan, or like the long-term plan.
Yeah, and I think that's definitely the goal of yeah, and some of it's going to be piece by piece over time in queue. Like that's sort of what the keps I was proposing in queue are more also trying to show the queue community, like, I think there's been a lot of focus on the scheduler library, not as so much on the workloads. Like, I know when I've talked to some of the maintainers there, like there was this idea where queue would be managing its own workloads in pod groups, because there are some advanced features for queue where queue does need to preempt, like do sub preemptions of the workload. And that's where I think we need to probably better draw the line about, like, I don't think queue is going to be able to solve these problems without input from the controller teams. And right now, I think they're kind of doing a lot of, like, they can manage a lot of things inside of queue without needing some of the controllers, especially with stuff like leader worker set or deployment or the pod integration, which causes a challenge. But anyway, sorry, we're way over.
Yeah, let's untangle, untangle this and take the conversation to different controller maintainers or sub project maintainers, and start this conversation, like with LWS and JobSet and entry, of course. But let's have this as the goal is to untangle these problems from out of queue, because queue shouldn't do that, right? But it has to be this way to serve everyone. Okay, so let's help each other having another issue in queue, maybe to have all these like things that we need to work towards from scheduling perspective and from workload perspective, and let's start to fix them one by one. Okay, sorry for being over time, everyone, and thank you for staying. And thank you, everyone. See you next week.